Thank you, Rikesh. Good to have those of you back. And, I hope we will pick up on some of the points we were talking about last two sessions. So what I'm going to do, like we did last time, is to very quickly go through some of the questions which were sent to me at the end of that course. After the end of the last talk. And today what I want to do is to explore this idea of scientific method in a little more detail. And as I said, since this course is about science and society, my interest is really about exploring the larger social questions around the idea of scientific method, particularly because, especially in the Indian context, it seems to be a very powerful idea which has influenced a large number of, social discourse, particularly on rationality and so on. So I want to use it to look at really, how to think through that particular idea and hopefully show its complexity so that it gives us a base to start talking about more meaningful engagement between science and society. So very quickly, to answer some of the questions which were raised, and as I said, there are many which fall into themes which are going to come later. There are quite a few on science education related to questions of science education, or rather the larger questions of education, which I will definitely do in a separate section on science education, as I said. I'm keeping all these questions and I'll use it when I come back to those questions. There are also the important questions about language and hierarchy. And again, we saw that as a very central question in the construction of a scientific discourse. In fact, that's something which is not just an important problem for science education, but it is an extremely important question in the context of science and society. What do you do about the question of language, the technical notions of language which is present in science, not just mathematics, even the way science modifies English and writes its discourse in a particular way. Scientific texts are written very differently, and that has serious questions about possibility of a democratic knowledge system which can be spread across the society. So again, part of it will deal with education, but this is an extremely important question on hierarchy and authority. When I do the more parts on the social issues, I will come to that. And there's one question about trusts, which probably continues over last times, which was eventually, to put it in a simple way, should you trust the scientists or should you trust science? And I think today's session, when we talk on science, will hopefully give us a way to ask this question. And there are also 3 or 4 questions on Ayurveda and knowledge systems. What do we do with these kinds of questions about knowledge and the claim that these are science or not science? And I'm sure many of you are aware that some of the pioneering work at the interface of Ayurveda and biology is for part of a discipline or a sub-discipline which calls itself Ayurveda biology, and there are some very interesting work in that. So that question of knowledge will also be addressed a little bit in today's session. There was an important question which makes the point that there has been a rise in science education, but there's been no effect on superstition. What does it say about either science education or about the hold of superstition on the social imagination? Again, this is a large topic, and maybe at the end of the question on scientific method, we'll have a better handle on this, on what constitutes science. And more importantly, it's a question about science education. What should science educationists be teaching? And again, as you know, in science education, since so many of you are professionals in that area, the debate on whether you should teach nature of science or whether content of science has always been a part of a problem within science education. And if there is an excessive amount of teaching of content of science as it is happening today, will that really impact the questions of superstition, blind beliefs, etc.? There are a couple of questions on preparation. One was on the idea that the very idea of preparation, as I was telling you that, the world appears to the scientific gaze in very interesting ways. It is present before, as the world is present before you and me in the same way as it is to a scientist. But what science talks about depends on the way it orders and it prepares the objects around it to talk about. So for example, when I mean objects, we also saw that it prepares both objects and phenomena. So one of the questions was that the very idea of preparation implies interdisciplinarity, and I think that's a very important point. And science has been the first discipline in which interdisciplinarity has been integral to the growth of science. For example, when you had the use of mathematics within the sciences, if you really look at it carefully, it's really an interdisciplinary engagement between two disciplines called mathematics and the sciences. Now, you can naturalize that phenomena by saying, without mathematics, you cannot have science. But really, the constant tension in this problem in philosophy, which is called the problem of applicability of mathematics. What does it mean to apply mathematics? That problem really continues to reflect this question about actually mixing two different disciplines. The preoccupation of the two disciplines are very different, but yet they seem to draw upon each other. Interdisciplinarity is central to all sciences because people often say, and which many scientists do not like, which is that chemistry is reducible to physics and biology is reducible to chemistry, which is reducible to physics. So eventually, in the kind of a nestedness of disciplines within science, you have mathematics, which is a kind of a transcendent thing because mathematics is not an empirical science. But then you have physics, and then what physics develops in terms of its theory and understanding of the world is used by chemistry, and then the chemist, what is being done by the chemist is by biologists, etc. And as I said, both chemists and biologists don't necessarily like this model. There is some truth to the way in which theories settle down from one to the other, but in a very interesting work on philosophy and chemistry and philosophy of biology, it actually shows in what sense chemistry is distinguishable from physics and how biology is distinguishable from both of them. So that interdisciplinarity question is very, very much part of there. There was also another interesting question about preparation, which says that, well, for many examples, there are no preparation. For example, I think the person said about lizards and plants, that there is actually no preparation as such. Those objects are available to us. Now, what I wanted to suggest is that when I was using that idea of preparation, that even a plant and a lizard has to be seen under a scientific gaze. And what that means is that you have to isolate certain characteristics of that in order to make it an object of science. So as I gave the example of a simple example of a falling stone, it looks like a piece of motion, the stone is falling down, but that can lead to all kinds of descriptions. As I said, you can talk about the light reflecting off it, the sound it makes as it falls, etc. But when you reduce it, when you prepare it in the context of measurable concepts like height, time, speed, acceleration, you enable it to become an object of discourse of science. You become an object of inquiry for what is called as science. So that's what I meant. So that happens to the lizard and plant. All of science is not really a complete description of a lizard or a plant. And look at chemistry, it's a classic example of this. Chemistry is a very sensual topic. When you talk about things like chemicals, it's filled with colors and sounds. And all my memories of chemistry is these wonderful things, bubbling smells and colors of all kinds, sounds, which happen in test tubes and in your laboratories. But a chemistry textbook, as a scientific textbook, is not an analysis of these colors and sounds and taste and smells. And these are the qualities which are not really part of your scientific description. In one philosophical traditions, this is called secondary qualities, and therefore it's not important, etc. But that's the point. Chemistry is just so rich in this sensual world, does not find a scientific importance in using their descriptions within chemistry. So this is something which, of course, chemists have very well aware of. So that is what I meant in the larger sense of preparation. There are a couple of questions related to the questions of religion and faith. When I do science and religion, I'll come back to it. And there are a couple of very important points which ask the question, to rephrase the question, how much science should one know to talk about science and society? And it is also related to another question of how social scientists should think about science, what should be the training, etc. I think after today's talk and on Thursdays, we'll have a better way of engaging with this question. Which also means that the corollary question is, should scientists be trained in SSH? We know what is happening in the way in which SSH departments, social science humanities departments, are being dealt with within our IITs and ISRs, which are so well funded. I still think there's a great gap between a meaningful, respectful engagement between the social scientists and the scientists. And this includes, students who take SSH courses and so on. We will, I'm sure, have occasion to talk a little bit more about it. Two very important question also is, how do we move from the ideal to the real messy world? Something which I will look at today. And there is also another point, a kind of counter to what I was saying when I was talking about the enormous production of scientific knowledge in terms of academic published papers. So the person also points out that the search for the new is there in all disciplines, and the very idea of discipline is that there's always a constant search for the new, and so on. I think the quick answer to that is really that much of the ideas of modern academic productions, including in fields like social science, including in fields like humanities, which includes philosophy, literature, etc., have been driven by this model of science, where the production of the new becomes is almost an end-all goal for what we call as academics. And the conflict of this tension between just huge kind of production, the pressure on all of all the academic, the community keep producing, has led to a lot of very serious discussion within higher education. And so I would think that that is really catalyzed by this particular model of science. And moreover, the kind of publication volume in science overrides everything in the other disciplines. I will give some numbers today to factor this into what we are talking about here. And and there's also an important point which says that, unlike what I was probably trying to say, that scientists seem to have too much of a say in running society, in things, that this person points out that it's a government and bureaucrats who demand scientists to solve a problem, and scientists just do it. I think this is a valid point, and when we do further on this relationship between science and society and the various ways in which this happens, we will see if we can make sense of it. The last question I will very quickly answer here is again an important question which was asked about Ptolemy and Copernicus. And the question was that, I was talking about how very similar set of data, sameness in some kind, can lead to very different theories, which both Ptolemy and Copernicus had access to very similar data, but yet you had two completely different theories. One was the Earth as a center, and the other is the Sun as a center, the geocentric and the heliocentric model. And the question was that Copernicus perhaps had more data available to him compared to Ptolemy, and therefore there is a growth of a theory rather than a different kind of an argument that the same data can support different theories. It's a very important problem in philosophy of science on theory and underdetermination of theories and so on, the relationship between data and theory. But the quick answer to this, and I would suggest all of you, and especially the person who asked this question, to look at a very interesting book by Richard DeWitt, D-E-W-I-T-T. The book is called Worldviews, An Introduction to the History and Philosophy of Science, 2010. Well, there's actually a very interesting two separate chapters on Ptolemy and one on Copernicus, where this particular question is discussed in quite great detail. And what we can recognize from that is that the kind of data which was available to them was largely the same, for the simple reason that they were both, it was an observational data. It was not an intervention data. It's not like doing experiments in order to create more data. They were observing the heavens, and they were both working with a model of fixed heavens, a sphere, or the sphere of the fixed stars. The only difference was the Copernican sphere of stars was a little bit larger, but both of them, and remember that there is a gap of nearly 1,400 years, and after the Ptolemaic, and we should also remember this is a very Western story of this question. I'll very briefly tell you why I say that. So like Ptolemy, Copernicus uses epicycles, deferens, and eccentrics as ways of, it's that geometric configuration to do computations. And very interestingly, of course, in 1400 years, there are some new data, but since the model was of a fixed sphere, there was really not too much of a change of data. And it also happens in the 1400 years, some data mistakes had been changed, but then new mistakes had also crept in. And therefore, it's actually quite an interesting question as to how, with all this kind of differences of, with the mistakes present in data, etc., that you actually can come up with a model which seems to be true in a very important sense. One of the points which David also makes is that they also use the same philosophical and conceptual facts such as perfect circle and uniform motions, and therefore in a large sense they are both comparable systems, except in one the earth is the center, the other the sun is the center. And in fact, it was Copernican system which went against observation, because it made a point which was completely against what was naive observation, that the Earth was stationary. So, and there's also a very interesting point about how the move to the heliocentric model was influenced not just necessarily with the data, but with a larger set of, philosophical and conceptual world which were important to Copernicus. This is an important point. It's a great entry into how we want to begin today, because it shows that there is, of course, you have questions of data, you know what you can say about the world, you can have an idea of a scientific theory, a conclusion about something about the world, but the movement from data to saying something, movement from experiment to describing the world, the movement from observation, experiment, data to knowledge about the world is far more complex than just the data alone. And one of the things which influences Copernicus is Neoplatonism, which is also has very deep theological connection to the earlier Platonic philosophy. So you see this all the time. You see this among the most important contributions and developments in science and mathematics. They're very deep theological roots within the Western tradition. There is very difficult for you to find a dissociation from theological interest and the growth of Western science in terms of conceptual understanding, in terms of your ability to look at something in front of you in a very different manner. So this raises really therefore the question of, which I think is the fundamental question about science, because remember that science is really about, in a very simple sense, science is about nature, it's about a description of the natural world. And the description of the natural world depends on the senses, the experiences that you have about the world. So that the whole scientific project is nothing but finding a way to move from what we see around us, what we observe around us, to saying something about knowledge of the universe. And knowledge of the universe, when I say knowledge of the universe, you need an account of what you mean by knowledge of the universe. And here is where the most important discussion on science and scientific method happens historically in the development of what we call as modern science in Europe. And that is the very simple question of there are two things here. One, how can I move from my observation things, my observations, my experiences, into saying something about knowledge? And what is the model that they are talking about knowledge? Given that European science derives to a great extent through a connection, in a sense, historians would say an artificial connection to Greek civilization, the definition of knowledge which becomes so influential in this debate is about knowledge which is certain, which is absolute in some sense, which is not open to doubt, which is not like perception. Because it's actually a long philosophical debate which happens about the nature of knowledge, which is dependent on perception. And since perception cannot be trusted, you cannot trust your eyes and your whatever, ears and smell, etc. They cannot really be the ground for certainty of knowledge. And the model for the certainty of knowledge comes from mathematics, for the Greek tradition, which is borrowed by this scientific tradition. And this is really an important point, because repeatedly you find, both in philosophy and in the origin of early science, that trying to model either philosophy or the idea of science on the model of the certainty of mathematical knowledge, and the model for that is Euclid. And Euclid's geometry is a phenomenal creation, in the sense it's a system of five axioms, in which there are discussions on how many axioms you need. And from those axioms, that is the starting point, those are the foundation bricks. From those axioms, you should be able to deduce, and that's a logical point here, which enters into science. You should be able to deduce all the results of geometry, planar geometry, what is called as Euclidean geometry. And that's a fascinating system, to think that you just need 5 bits of information from which all knowledge about geometry can be produced. And the attempt to create sciences based on this model of just, in the Aristotelian sense, demonstration. Knowledge just through demonstration, in the sense, knowledge, if you like, I'm putting it loosely, knowledge through just thinking, knowledge through just making argument, logical steps within your head in order to come to your conclusion. Empirical science challenges it because the basic data needed for that comes from the world. So always a great challenge in science is to be able to say, how do I move from taking this messy, approximate data which perception gives me and convert it into true, certain, indubitable knowledge. This is really the basis, the background from which the very idea of scientific method comes. And to make sense of that, we need to look at it a little more carefully. So I'm going to explore this particular idea, and I'm just going to share my PowerPoint. So we have some. Okay, just give me 1 second. We are starting. So I'll just to remind you, I'm going to start with what we spoke about, the different meanings of relation between science and society. I'm not going to spend any time on this, just to give you a recollection of what we spoke 2 days back, that the word relation between science and society can be understood in different ways. For the purposes of this lecture, I want to use 4 different ways of looking at it, which is influence of science and society. So this helps us break down the problem into smaller, handleable way. So influence of science and society, influence of society and science, science as a social process, and society as scientific. So much of what I'm going to talk about on these 4 days are going to be around this kind of a breakdown of 4. As I said, just as a way for us to get a handle on smaller problems rather than look at a very large problem. So if I look at the first categorization there, which is influence on science, on society, and here I'm calling it on everyday life social, on the social world, how does it impact us? Here too, I want to break it up into smaller parts. One, of course, is through technology. And if perhaps for most of us, our engagement with science remains only at the level of technology. When we say that science is engaging with society, for almost all of us in our society who use technology of various kinds, or dependent on technologies, it becomes has become a very important part of our lives. And through it, it has changed an enormous number of social practices, and it has influenced human interaction, social practices, etc., both at the societal level and at the level of individuals. So, there's been a lot of work in this, and I'm going to talk about the question of technology only tangentially later. So I'm just pointing out how we can break this question again, influence of science on things. The second is through knowledge, by looking at the influence of knowledge produced by science, such as medical knowledge, knowledge of the universe, and many other kinds of knowledge systems of all kinds, from creating chemicals to, your soap and your disinfectants and so on, enormous number of things which are produced as knowledge within the larger domain called science, and they enter society, and through that one can ask the question about how does all this knowledge influence the functioning of a society. And as we know very well, as we can see today in COVID times, the way in which medical knowledge has been understood and practiced and supported, which is now largely very techno science of the highest order compared to the old model of science, it has completely changed the way we understand the basic things about health, illness, birth and death of humans. So there is another important influence. So one can analyze that aspect of the influence. There is also an important part, particularly repeatedly arising in India in the context, in many contexts, including the context of scientific temper, including questions of caste, including questions of the engagement of the left with social reforms and so on. And that is through a type of reason and rationality that science somehow captures a kind of a reason, a particular way of thinking about the world, and therefore a scientific attitude, a scientific rationality can actually help us resolve social problems. We have already discussed this very briefly, but I want to look at, so this is one way in which science influences society in a very deep way, particularly, as I said, in present day context, I think globally. And so what I want to do today is to really basically look at the last two, the technology where needed, I'll come later on, by looking at what is special to the idea of scientific knowledge. And we need to acknowledge that something is very, very special in the way scientific knowledge is produced, and also try and understand what kind of reason and rationality could explain some aspects of the scientific knowledge. And sometimes when we are caught up so much in the discourse of science and how we are caught up in this idea of technological determinism, that without technology we cannot live, etc. I often think of how life was 1,000 years ago or 500 years ago, before all these questions of so modern European science came in. So I don't want to say no science, but that's a contentious question. We will see if there are questions on it later. But, some of the greatest contributions in human thought, including things which lead to science later on, which includes mathematics, which includes philosophy, which includes music, which includes theater, which includes some of the most important, profound reflections on language and the meaning of language and so on, all happened before these so-called modern scientific revolution. So this is just to, for those who think science and technology is so deterministic that it's impossible to imagine the idea of a human society without it, it's always useful to go back and reflect on it with all its problems, etc. It's not about wanting all of us to go back there. No, it's not about that at all. It's just about thinking, what could a society, what sustained societies at that time? What kind of knowledge systems made society function in various ways that it did? Okay, and this is just to show us how to look at comparisons when you are immersed in something and you don't know how to step out of it to look at it. Then this is one particular exercise which is very useful. Okay, so some people had asked me about this and I forgot to do this. Much of the material we talked about in the last two sessions, much of it was, part of it is drawn from my book, What is Science, which is an introductory understanding of history and philosophy of science. And that's why I wrote it for National Book Trust. And in my other book on Indian philosophy and philosophy of science, we look at chapter 4. It summarizes all the major themes of what we call as, philosophy of science, the dominant philosophy of science in the Western tradition. It looks at questions of logic and science, deduction, induction, all those kinds of questions. And both these books, everything which I put up, it can be downloaded from the net, so for free. So you can just click on it and take it if you're interested. And the question I ended last time with about how the discourse of the real needs so much of a imagination of the unreal, which is what really characterizes scientific discourse for me. The fact that mathematics are not physically real. And within mathematics, things like imaginary numbers are so central to the development of science, really raises a very interesting puzzle, a philosophical puzzle about the nature of scientific discourse. It's about basic language. That is, if I want to describe a real world as truthfully as possible, what kind of systems of language do I have to use in order to be able to do that? So what is the language of truth, if you like, quote unquote? And that is really the point I discuss in this thing, which we spoke a little bit about. And for today, I'm going to be, at least, if we had time and I did this as a course, I would like to discuss this book more. I think it's an excellent book for many of you who might want to read this on scientific method, because it is also sensitive to the larger issues of the scientific method. And it is, shows the complexity of drawing on historical, philosophical, and social methods in order to understand what scientific method is. And it's really about a series of case studies on people like Newton, Bacon, Galileo, etc. So it's really worth doing it. And I'll give you a very quick, brief, insight from that book. We won't discuss it more, but if there are questions, we'll come back to it. And for some of the material I'm using today, I thought for those of you who are interested, because I won't have time to discuss all of them much, so I'm just going to be saying very little about it. I'm giving this article of mine on the Wire because I think almost all that I want to say about scientific temper and scientific rationality is present in this piece, which was a response to another article written in Wire, which was a critical response to my op-ed piece in the Hindu on the March for Science. And this, of course, then led to some other people writing, including Rennie, who wrote about the questions of caste in Indian science, and other people who added to that particular debate. The NSF data on number of papers and most influential papers, these, you can always search in the web and get it. But I thought, in case you're interested to know more of where I get the numbers which I'm going to present today from, they are from this particular, these 3 papers, which you can look at more carefully. Okay, so the question about scientific method is very simple. And this is a question which which is taken for granted by scientists, and I do not, let me put it this way: I still run across scientists all the time who, when you talk about the special or about the nature of science, would always come back to the question of scientific method. That does something which is methodologically special to science. If you look at the debates on Ayurveda and medical science, for example, it is again about questions of scientific method. And if you want to talk about any kind of distinction of different disciplines within science, it's about the fact that there is something called a scientific method. And, Gower begins with this point, and it's an important point, that he says that, well, philosophers have always been a bit skeptical about this claim of a scientific method, and whether there is something really called a scientific method, and whether one can identify something called a scientific method. One way to answer that very quickly is to say, well, we will accept that there are many methods, just like we now would like to talk about, not about one homogeneous society, but many societies within a society and so on. You might want to say that there are many methods, many ways of doing something, if you like, very loosely, right? Many ways of inquiry, because inquiry is too big a word. It's too, ambiguous. You can fit in many things within it, but there are very specific ways. And in the last talk, we saw some of the ways which characterize scientific, ways of looking at the world, like preparation, laws, etc., etc. But if you really look historically at what actually happens, you do find that the early founders of modern science, if you like, if you want to use the word, and I'm going to use the word modern science qualifiedly here because it's easy for me as a form of communication, which is basically the European science, and in the history of which people will refer to Galileo as the quote unquote father of modern science, etc. So there is a tradition of, earlier to Galileo, Copernicus, Kepler, etc., leading up to Galileo, to Newton, and so on. So if you really look at what Galileo does, what Newton does, what Francis Bacon does, and after them, very important, influential, philosophers and scientists, including Mills, Poincaré, Einstein, etc., all of them seem to be saying something different about the idea of method, although the central point, which in a sense brings all of them together, is the formulation of what is an empirical science. That is, what do I mean by that is, what does it mean to derive certain knowledge, that is indubitable, very high, undoubtable knowledge of an empirical world, of our empirical reality. Again, this question, we should remember, comes from a long history within the Western philosophical tradition, and which is that when mathematics, as I said, becomes the model of this universal, atemporal, that is a truth which doesn't depend on time. It's not like 2 + 2 = 4 was correct 10 years back and 10 years later it's going to be different. No, an atemporal truth, universal truth, the same truth for all societies and cultures, etc. This view, which is so deep in the mind of the scientific community, which every day when you talk to these people is reproduced over and over again, which shows the importance of how deeply it has gone in. It is that question that you're asking. Can science, what you're basically asking is, can scientific knowledge become as good as mathematical knowledge? Okay. And for Newton and Galileo, that is really the fundamental struggle. That's what they're trying to articulate in the context of a method, because they're coming from a tradition influenced by Greek thought, influenced by the idea of demonstration through deductive logic, through particular kind of just thinking, coming to a conclusion independent of how the world is. So this is involved with a very interesting philosophical idea of necessity, that these truths which I want to talk about are necessary truths. They are not contingent truths. They are not dependent on other factors. It has to be the case that these have to be true. That kind of knowledge. So it's really not, so when we really talk about scientific method in this historical context, we are asking a different question. It's not just about, is it just scientific knowledge? No, you are saying, can scientific knowledge be as true as, or at least have the form of, or approach the kind of knowledge which is more certain and indubitable? And therefore, it is not an accident that Galileo and Newton, who were as much, perhaps, if you want to call them quote unquote philosophers, I mean, they were called natural philosophers. And so they are working within a philosophical tradition. And like I told you, maybe the last session, that Newton has his 4 and sometimes in other editions 5 rules of what he calls as the philosophical method in doing physics. He's not in doing philosophy. He's not doing philosophy in the sense of Aristotelian philosophy. But for all these people, they are very clear about one thing. And this is a very important, I think, a very important understanding of what a scientific revolution is. They recognize the importance of finding, finding ways to talk about the truths of the natural world in a model which is based on certain philosophical methods. And I'm saying this again, I'm re-emphasizing why it is such a big revolution, is because, when people have talked about why science is not developed, modern science did not develop in China and India, the famous Needham question, very often people say that, Needham has his own answers. There have been many people jumping into this debate on why it didn't develop. But there are other arguments. For example, work by people like Arun Bala, who has written this wonderful book on dialogue across civilizations, which talks about the multicultural origins of science, that the way in which the data, the basic knowledge which was needed for the European civilization, including Copernicus and Galileo and Kepler and Tycho Brahe, actually came from many sources. They drew upon earlier work, not just from Greek, the larger Greek idea, the Greek civilization, I guess. Although historians would, cringe when we say the word Greek there, because it's a very complex of other civilizations, but also from developments from India, including very important pioneering developments in mathematics from India, which goes into Europe through the Arabic Islamic philosophers. And it is the Islamic philosophers who bring this synthesis, who bring this unity of ideas from China, from India, from Greece, etc., brings them, synthesizes them, and acknowledges them and transmits them to Europe. And it is based on that particular flow of ideas from different civilizations which leads to the great scientific revolution. And therefore, this kind of a multicultural origin of science has also been, I think, very important for many of us to consider. And I'm sure, like in all disciplines, there are people who will criticize one view or the other, but we have to be able to look at it in a far more complex sense. Now, the point I'm going to be talking about here today is, after I tell you what some of the problems of scientific method and some of the strengths of scientific method is to come back to a particular question of social practice and the social practice associated with scientists. When scientists tell us that, we have a method, be logical, use science. And as I was telling you, media is completely, it's not just about the COVID. I can't listen to, for some reason, I think the American media has, of course, become far more obsessed about it. It's also part of a larger politics related to Trump and so on. But this question that, use science, use science, use science. And today I was seeing something about this unfortunate things on Black Lives Matter, what's happening there. And one of the persons who was running, these training camps to make people aware of different races and so on. She's saying we have to use science for it. And I found it interesting. And I think it's important that we listen to them and try and make sense of what they are saying, rather than say that they haven't understood what it is. But I think it's something very important about why do they use the word science? And part of it is we're being told repeatedly by the scientific community, you have to be scientific, this is not scientific, that is not scientific, we're not using scientific methods. So one question is to ask, do scientists use this method in their everyday science? Note that I'm not asking in their everyday life. I'm not entering that domain. I'm not, okay, that's not an important issue. Although they want us to use this method for our everyday lives, including questions of, caste and so on. So I want to understand how to use this idea more fruitfully and not in a very naive and simplistic manner, because the moment you use it in a naive and simplistic manner, it's easy to demolish it and say, no, I'm not going to do it. So I want to try and see the strength of this in order to recover some parts of this idea. So in everyday science, in the day-to-day science, what people are being paid for every day when they go to all these labs, sit in their offices, and they do science, doing of science. What is the kind of, how much role does the question of logic, evidence, reasoning actually happen in their minds day after day? And this is not adding pressure to scientists. I'm trying to show an important characteristic of doing science. That's the reason I'm saying this, okay? So we know that, scientists are so different. They belong to different tribes within one master tribe called science, and they do things very differently. The theorists do something, computer science, people who work with computers do something very different, and, experimenters, different mathematicians do something very different, etc. So it leads us, like it has led many philosophers of sciences, to suggest or to ask the question, is scientific method more to be understood as an ideal model of how to do science? So let us assume that the everyday practice of scientific practice is not filled with these kinds of, deductive, inductive thinking and doing everything at that level. It does not mean that there's nothing called scientific method. There's no force to the idea, but can it function as an ideal? And you can immediately see ideals shifting into ideology very easily, and that is part of the problem. But as an ideal model of how you would like ideally to understand science, it's a very powerful idea. So without getting rid of this idea of scientific method, let's talk about the possibility, could it be like an ideal method of how to do science? And if you have the ideal method of scientific method, what we would see in Gower's book on scientific method are some of the following points. One problem which historians and philosophers would have, and sociologists, of course, would say that, well, this simplifies a very complex creative process. Science is not, a linear task force. It is not just saying you do this, then check whether that is conclusion of some kind, then do this, etc. Doing science is a far more complex creative process. Now we know the potential response to this, which is that doing science is not really science at all. Like I told you, I think in the earlier thing, Reichenbach's, the famous discussion on discovery and justification, context of discovery and context of justification, tries to demarcate the question of doing by saying, well, science has a component which is about creative and discovering things which can happen accidentally, etc. But the real meaning of science lies in the domain of justification. That's where the question of logic comes in, because how do I justify what ideas I get, how I accidentally discover something? And that's a very, very true, and I think it's an extremely important part of all academic processes, by the way. It is not just about science.
Hello. Hello. Sundar?
Yeah, Ritesh, we lost the connection, but I think
Yes.
I'm back now.
Okay, great.
Yeah, I'm back. Okay. Sorry,
Yeah,
I'll just
but
have
we
to go
can't
on.
see your video.
Okay, I'm just turning on the video. No, I'll just go on to the, it doesn't open the video. I think you'll have to do something
Okay,
from your side. But anyway, I'm going to share the screen, so I don't need the video now.
okay.
Unless the screen is already shared. Let me see. Can you see the screen? No, right?
No, not yet.
Then I'll share the screen.
Yes,
Yeah,
yes, we are able to
now we
see
can
it
see.
now.
Okay, great. Okay. Can you see the screen now?
Yes, we are able to see it.
Okay, great. Okay, so one, it simplifies a complex creative process, but we know how to take care of that question. Oh, but now I have to reshare this because it doesn't work now. Sorry. Just give me 1 second. Okay, there we are. Share. Okay. Rudesh, can you see it now?
Now it's clear. Yeah.
Okay, great. Thanks. So it also does something very important, and this is something which we really have to think about very deeply. And again, something known very well to scientists, but it's become so much a part of the hierarchy of science, which is the second point I'm talking about, which Gower mentions. And there have been very many interesting work in philosophy on this, which is about the fact that stories of science and models of scientific method have largely ignored the experimenter, the person who is doing things with her hand, who is creating these new instruments, who are creating new ways of looking at the world, new ways of observation of the world. And in fact, it's very interesting that for a very long time, philosophy of science was dominated largely by, looking at examples of physics, like I myself am doing, but I'm doing it so that to connect you to some historical, the literature in this field, but I'll come back to biology later on. So it does, and also it never talks about the method of an experiment, the complexity of doing an experiment, and how, I think some of the best work on it actually first came from sociologists of science, like the book on called the Golem, who really point out how to really look at an experimenter's work by looking at their lab notes, by looking at what they have chosen, what they dropped out, how did they do an experiment, how were particular experimental results confirmed, accepted, etc. And I think that's a very fascinating story. And therefore, the argument which Gower makes is that the scientific method does not seem to take care of that. I'm not able to move my screen, sorry. I think
There's some problem at your end.
no, my thing is okay. I was asked to start. Okay, let me. Maybe that thing of you had stopped my video. Maybe it started something. I don't know. Okay. Let me try the share again. See, it's, I should stay here. Stop. I think I don't know. Just give me 1 second. I'm done. It just not. Okay. Yeah. Okay. We also have a lesson from the history of science that rarely does an experiment prove one hypothesis over others. And we know from the history of science, again, very detailed work, I think some of the best work on trying to understand science comes from historians of science. The results which we have, which are never ambiguous. If you just look at all the historical work on Newton and Galileo, for example, you can see how, how complex this question is, because, there have been claims that, Galileo was one of the most important methods which Galileo raises is this question of, the idea of motion and, different things related to the question of motion, including the dropping, stones from heights of buildings, including the Leaning Tower of Pisa and so on. And historians point out that many of these experiments may not have been done at all, and it didn't matter, because one of the great contributions of Galileo was to to really focus on the idea of thought experiments, something which gets revitalized through Einstein, the importance of thought experiments, that you don't have to go do it in the messy world, but you can imagine doing it, and through your processes of deductive thinking, you can actually come to know exactly what would happen if you did the experiment just by thinking about it. So there are, how much of these kinds of things which we attribute to these people are true or false is very open. Some historians say that this famous story of Apple falling on Newton's head is also very apocryphal. It's not, there is no evidence for this. So primarily the question of method goes back to just this, as I said, the logic of relating evidence with conclusion, which is, as I was pointing out, it's a very old historical issue. And finally, what Gavar also points out is that in reducing all of the activities of science to a scientific method, a kind of a particular epistemological action, an action which is geared towards understanding knowledge, it misses the historical and social context of any work which is being done in science. And that is, if there is anything with science studies I've shown, it is not that the historical and social impact of science reduces the value of the scientific knowledge or scientific method. It just shows how much it plays a part in the production of scientific knowledge. And this is a far more complex question than what I'm trying to say, but I want to focus on, so we will come back to that much later, of course. But one question which I want to do in the remaining part of our talk today is to take this seriously and say, what is this fascination with the question of scientific method, even though empirically we do not seem to have a very clear-cut evidence for this. That is, if you look at scientific method simply as saying there is empirical data and you have theoretical reflection on the data which explains it and describes it, and then you construct theories of science and so on. Now, when we say that, there are many intermediate steps, there are many other influences which operate, and that is what really people who look at who question this idea of an ideal scientific method are saying. But there is one aspect of scientific method which is extremely important, and which is again part of our social discourse to such an extent that I'm going to just try and make sense of this, which is the association of the idea of logic with science. And the reason why the question of logic is associated so much with science is very often, including our questions of reason. When they say, look to science for this, what they mean is, well, there is something about the question of logic which is associated so strongly to science, and scientific method captures it. And when I tell you be scientific or do science, in a loose sense, I'm saying be logical. And this is actually very interesting, because if you go back to the question of a very simple definition of what is logic, and what is the kind of logic which is present in the kind of sciences we are talking about, they are primarily, logic is, a one-line definition is an analysis of arguments. Logic is an analysis of arguments. I mean, not people arguing. Arguments are, coming to conclusion based on premises. So the most simplest example, like syllogisms, I have two premises and I come to a conclusion. That's one very important idea of logic, which is related to deductive logic. And inductive logic is generalizations. So, any generalization, clouds are dark, so it is going to rain. The moment you see clouds dark, you think it's going to rain. That's part of your inductive thinking. So classically, in the Greek tradition, as well as in the Indian logical tradition, which is extremely rich and very complex and spread over centuries, these are the typical ways of looking at these questions of what logic is. That is, logic as forms of thinking, if you like, or structures of thinking, are ways of coming to a conclusion. To put it in more looser terms, you're doing logic when you come to a conclusion. The only question about whether the conclusion is correct, quote unquote correct, is to really say, not that because I may have come to a conclusion by guesswork or mistake, right? But the simple question is the conclusion supported by the prior premises? Is a conclusion supported by the data that I have? That is logic. You don't need anything more. And the real debate, if you really like, which is at the heart of the scientific method, is this tension between deductive and inductive logic in the Greek tradition. Or to put it loosely, in consonance with how people refer to it today in the Western logical tradition. The tension between the deductive and inductive logic. Okay, for those of you who are interested in Indian logic, we can talk about it later, why such a tension does not arise, etc. But, you know, I'm saying in the context of the scientific method, in the historical context we are talking about, it's really a tension between the deductive and the inductive method. Inductive method is messy and not always correct. So the famous example, I see one crow which is black, two crows are black, then I say all crows are black. That's an induction, but I could be wrong because I have not seen all crows. It's, you know, it is open to change. It's falsifiable, it is fallible, because I may generalize so much. We generalize about people all the time, and we may probably prove wrong when the person acts in a different manner. In contrast is deductive logic, which is absolutely certain. The notions of certainty, etc., are very deeply related to deductive logic. So this is not special to science. The reason I'm saying all this very quickly and briefly and hurriedly is only to point out these forms of logical thinking are not special to science. We do this every day. When you're thinking about what to eat for dinner, you're doing deductive and inductive logic. There's no human thought that you have which is not drawing upon deductive and inductive logic. So what is it that we are supposed to do when we are supposed to become logical when we think about society? When we want to think about caste, for example, what is that about logic? Or what is the thing that I need to have that is logical? Okay? And although this is common to our ways of thinking, it is very special to science because science sticks to it far more rigorously than our day-to-day lives. You know, so suppose I know I'm thinking of what to do for dinner and I realize, oh, I'm going to go out to this particular place and eat. And, you know, all my so-called data points, my deduction, which is that I ate there last time and I had a stomachache, therefore I should not eat there this time, something like that. Or that I've had 3 times before, I haven't enjoyed it, therefore the 4th time is also going to be bad. That's an inductive generalization. I'm using all of that, but yet I may override all that and still act and go to the restaurant. Okay? That's part of the, you know, vagaries of human action, perhaps. But it's not that you haven't done that logical and deductive thing, which is not that you didn't have the capacity to do it or you didn't think about it. But for science, it is this insistence on sticking to it. And most importantly, sticking to the logic of moving from observation to conclusion. So I'm looking at a blue sky, that's my observation, from which I want to conclude that light is scattering at a particular, according to a particular law, for example. I will have to be able to do that logically. That's what it means. That is, I can come up with any explanation for it. I can tell you why a blue sky means something, that's fine. But whatever I do, it has to be, you know, step by step, it has to answer to the question of logic, deductive or inductive. One of the most major questions in science, which then becomes an important question in Western philosophy and philosophy of science, is the claim which is that scientific knowledge is inductive, it's not deductive at all, and therefore scientific knowledge is always incomplete, open to change, the Humean argument of induction of scientific knowledge. But I will show you now that it's, I think, a far more complex point, and that both deductive and inductive really make a point. I'm raising this question also because keep in mind that this question of observation to conclusion is as much a part of social science as anything else. So I'm looking at, for example, questions of poverty. You know, I want to look at what are the indicators, what are the kinds of observations I have about poverty, from which to conclude to certain things I want to state about poverty as a social phenomena. What is that method? What is the way I traverse between observation to saying something about it? Observation to knowledge. Or what is that traversing? What is that kind of a question about this? Okay. And it's very important to also recognize, that's what I said about this consistently sticking to the logical question, is that the inductive question was understood within science very well. It is even understood within with Newton. It's not a, it's a very important question for him. That's why he rejects some idea of using hypothesis to knowledge, etc. But anyway, the point is that they recognize that induction seems to weaken the case, because induction is, as I said, I see black clouds, I think it's going to rain, and I've seen it 4 times, so I think it's going to, so I conclude that it is going to rain. I infer that it is going to rain. But what kind of a knowledge is that? Can I call that as knowledge, that it is inferring it's going to rain? So one of the most interesting, I think without it, it's really difficult to understand modern philosophy of science, is the shift into the mathematics of probability. So one way in which you can understand and move away from common inductive thinking. As I said, inductive thinking, we do it all the time. Somebody is nice to me one time, second time, third time, so I think, oh, next time I meet that person, he or she is going to be nice to me. So that's an inductive thing, and it may be wrong that day when I go to meet that person. But what happens in the development of science is that probability itself gets mathematized. It becomes, I would put it in this way, connecting to what we discussed earlier, it becomes measurable. So it is no longer like, oh, I think it will happen, there is a good chance that it will happen, etc. Just like what Galileo's dictum was, to do science is to describe phenomena with measurable concepts. Stone falling, describe it with height and speed and time, which I can measure. Numbers, quantitative. When probability itself can be done that way, you have made a great jump into bringing inductive logic into something truly within the domain of what can be called science. And the development of probability and the Bayesian model of probability, etc., have been extremely important. And I think that's where the real question of science really is present. Because the other science we're talking about doesn't exist at all. I mean, it's very rare. Almost all of science is at this domain of this inductive, generalizing, moving from data which into some conclusion I want to make, which is not completely supported by the data, like the Ptolemaic Copernican example. And that great shift into these ideas of probability really lead us into something extremely important, makes the logic of science something different. So having said all this, having told you very briefly the complexities of scientific method, drawing upon many of these ways of looking at it, one way we could look at the uniqueness of what we mean by the logic of science is that you cannot reduce logic in science just to deduction or induction. I'll come back later, I'll clarify it a little more, but if you ask me where deduction happens in science, the best example of where deductive conclusions are made in science repeatedly is mathematics. And this was the great project of Russell when he writes that book, on the showing how arithmetic can be completely reduced to logic. Arithmetic statements are reducible to logical inferences, like if and then inferences. So it also explains why you want to use mathematics to talk about observations. Because the moment you use mathematics, mathematics is the Trojan horse by which logic comes into science. So when you bring in mathematics, you're bringing in a deductive structure which is associated with certainty and knowledge, etc., compared to the more weaker idea of inductive logic. But still, I would say that if you really ask the question in what sense is science logical and what sense that quote unquote logical, I would say that given the historical and the philosophical discussions on it, empirical, just based on empirical data on how science is done, I think we will have to accept that science is a very complex mix of logic, imagination, rhetoric in various ways, which I won't get into right now, and which really makes this uniqueness of science and the logic of science. So I'm raising all this because I want to come back to this question of society. What does it mean for this notion of logic to be used within the social sciences or to reflect on social phenomena? The difficulty of reducing science to logic I've always been puzzled by that. Every time I talk about this in the public domain, scientists want to take this question of logic. But as a discipline, logic is not taught as subject to science students. I don't think anything has changed from my times. There are no courses on logic which I ever taught. You can do a PhD in science, you will not be taught a course on logic. You'll be taught a course on logic in philosophy. You do philosophy, the first 101 of philosophy will be logic. You're taught, I have discovered something engaging with the logic community in India is that many of them are very good computer scientists. And these computer scientists, for them, they teach logic. They do mathematical logic, computer logic. Logic is extremely important for them. Mathematicians have a sub-branch called mathematical logic, which they do. But physics, chemistry, biology people are not doing logic as a subject. And I'm not saying this as a criticism, but for many of the scientists who keep saying logical, they don't know that what are these different types of this deductive, inductive logic, or the type of reasoning which the philosopher Peirce talks about, abductive reasoning in science. I mean, for them, logic becomes a rhetorical tool. It becomes a kind of an ideological term for something. But they are right in some sense, because there is something about logic. We all know that. But it is something far more different in the context of science. So, as I already said, logic in science primarily arises through mathematics, which is the deductive theory. The theoretical structures are deductive structures, and it is through probability. And what I forgot to mention here is that it is through probability that we handle this question which one of you had asked in the end. How do you move from the ideal model which science begins with to the real world? And it is this idea of approximation is so important. And again, even many philosophers don't pay enough attention to it. It's like, I start with the question of, let's say, solving a simple physics problem. Like the example I gave you was a pendulum, or a Galilean example, drop a stone on an inclined plane, which students do in school. And when you do the theory of it, when you do the mathematics of it, you will begin by doing it as an ideal world, which is no friction, no air currents, there's nothing which is stopping the object flowing, no friction on the ground, no friction in the air. It's a very smooth ball. I'm not taking into account the shape of the stone, all of those things. But then you have to move from there to talk about the world. How is it that you can understand that matching? And in the case of social science, it becomes far more important, right? And that's why this question of what is a theory of approximation that you need, which will allow you to move from models to understanding the real world. One of the most difficult questions, and science does this pragmatically, not theoretically. It does it in, hit and run method, try and test it, see what matches, what doesn't match, etc. But having said this, I want to make one point, which may be contentious. It'd be good to have a discussion on it later on if some of you agree with it or may not, which is that I still think that the question of logic is central to science, not because of individual scientists thinking logically. As I said, that's part of human thinking in a very important way. And people who can think logically and think illogically all the time. It's not that once you think in order to think logically, everything you think about is going to be logical. We know that it is not true. But there is a difference between other disciplinary thinking and scientific thinking. And I would think of it in this manner, which is that for science, there is a relentless test of logic. And this is not necessarily an ideal picture. And I think, so when you write a paper or when you're doing something else, there's a constant, relentless test of logic at every step. And what does it mean to say logic? I'm not saying something very profound about what, inductive, deductive. It's a very simple thing which we are asking. Does the next step follow from this step? That's all. And you don't need anything else to really understand this, insistent hold of logic, which is, does the conclusion follow from what is there in the back, behind? So I say something and I want to say, can I say the next sentence? What is the next sentence which I utter? Is it supported by what I have told you before? If it is not supported, then I have to do something about it. I can't assert that conclusion. And this is operationalized in science through various ways, as I said, through mathematics, through quantitative techniques, through statistics, which takes care of the questions of probability, etc. So one way of understanding this is to say that the accepted scientific knowledge, if you really accept Newton's theory, Einstein's theory, and etc., I'm using only the big theories or major theories in chemistry or Darwinism, etc., you could perhaps argue that when these theories or when these scientific narratives are presented, they are presented with this logical rule on them that they have to follow the expectations of deductive and inductive logic at every step. But this is not true for practice of science. It is not true for the practice of everyday science by scientists. This is the accepted scientific knowledge. That is, including papers you see, including papers which get published. You would see this. You don't have any random statements being made. And if somebody says, I've done this experiment from which I want to conclude it, the first thing a reviewer is going to see is whether the conclusion is supported by that evidence. But remember that this is very common to human thought. If you say, oh, this person is a nice person, definitely you or your friend to whom you're saying it will ask, is all the observation you have of the person, is it enough for this conclusion? We do it all the time. But I think this kind of an insistency, a particular kind of quantifying this deductive logic through mathematics and inductive logic through statistics and probability is special to science. And also, there is a social character to this logic of science, which is that it is always answerable. So, for example, I'm writing a story and I'm just given I give you how things are around me, and I make an imaginative leap and tell you something else. And I'm just inviting you to imagine with me. I'm not asking you to say, hey, do you think that follows from what you told me before? I'm not interested in that question. So this pressure of being answerable, okay, which is a very social character of science, answerable to whom? It's not answerable to me. I'm answerable to you who is not seeing that. Remember a very, very important, metaphorical image which captures this is, the great Indian mathematician Srinivasan Ramanujan's creative output of enormously insightful mathematical results and mathematical structures. And when Hardy discovers him, in Hardy's own words, one of the most important things he had to do is he had to teach him mathematics. Basically, he had to teach him that you have to prove that. If the result is obvious to you, you may have seen it in your mind exactly and writes a complex result, which is, which even to Hardy is stunning to see how did this person come up with this. But the task of training, teaching, if you like, Ramanujan by Hardy, was to be able to make that result answerable in a social sense to other mathematicians, to other people who may want to know how he came to that conclusion, how Ramanujan came to that conclusion. And this I would put as part of the logical structure, because it's a kind of a logic which we need to really understand in terms of the nature of the logic which relates to science. And therefore, we can ask a larger question, which we will be answering down the line as we go along. Is the social science follow these principles? When you say that there are, social phenomena which you observe and you are saying something about it, is there, how does the transition from phenomena and observation? It could be like, what's happening in the country now. It could be about what's happening with COVID. It could be with CAA, various things. And what people are telling you and what you want to conclude about the nature of society, what people are feeling, etc. What is that link? That's really the fundamental question of what constitutes theory, right? And is that link logical in the senses, in the ways in which we have talked about? But you can go further, far beyond all this. So what I'm going to do with the remaining few minutes is I want to point out to you, and because I think it's extremely important for social scientists to recognize this, is that Science as practiced today has moved very far from these simple preoccupations of logic, deductive, inductive, the Newtonian, the Galilean, and even the Einsteinian method, etc. And I'm saying this because in my engagement with social science students, and for those who think they are still interested in the question of the relationship between science and the social science, or the meaning of science within social science, they still refer to science as if, the practices of science which are classical, which are very traditional, which are very old. Science has become so different today that for us to be, and many of the scientists who are invoking this ideal scientific method, invoking Newtonian experimental observational method, are not doing those kinds of sciences today. I'll just give you a very quick example of how science is very different today. The first point is, of course, just to give you some numbers, around 26 lakh papers are published. So 26 lakh papers are published in 2018. Okay. You want to sort of, that's so big that one way to maybe get a handle on it is to say per day in all these branches of science which I spoke about, there are nearly 7,000 published papers. And remember that the mark of a paper for it to be published is it has to be original, it has to give you something new which has not been said before. 7,000 are published papers. But as I also mentioned earlier, that there are many more papers written, because even if you take an average of 20 to 30% acceptance, you still have tens of thousands of papers produced every day. All of them claiming to new knowledge. And all of them claiming to scientific method. Is there? What is this idea of method? That it can be reproducible like this. There's the Nature article which I cited earlier. Please go check it out. It says 2 papers per minute pour into the PubMed database. Okay, 2 papers per minute. It boggles my mind, because, I'm just wondering, how do I read those things? How do I even think of reading those things? How do I even know how knowledge has been accumulated? Which knowledge do I want to really look at and learn from? Today, they expect that doubling of scientific output happens once in 9 years, which is, if already you are producing, I don't know, lakhs and millions of papers, every year, you're actually, the whole amount of science produced till today is going to get doubled in 9 years. This is a ripe topic for social scientists. Only social scientists who can make sense of this. What is this activity? What kind of a production is it in a society that produces this kind of intellectual value and originality, or whatever this notion of newness means, to this level? And what kind of science is this? What are they all talking about? Because obviously when Newton is producing his work on gravity or theory of motion or theory of gravity, equations of motion, etc., it's a very high level science in some sense. You can't expect all science to be that way. But one interesting point is, you could ask, is scientific method the catalyst for this production of this social production of knowledge of this magnitude? Is there something in which, what really makes this happen? How do we understand this? So added to this is this other problem, that the type of science being today has changed drastically. Many of the questions of method, which these people still use, many of these old questions of logic have to be really challenged again by social scientists. There is, in all the work done, there is a much less fraction of this theoretical, analytical, mathematical work, which is not that it was always more earlier, but it has led to very many different kinds of just simulations and computational models, an enormous amount of them. I'm still surprised as a grad student when I discovered that, we all had to learn all the complex questions of integration and so on. And then they came up with these softwares like MATLAB and stuff, which could do these complex integration, which you had to learn the tricks and know how to do them with the computer. So you could now produce scientists who can actually, you know, people shouldn't misunderstand me on this, but I'm saying it becomes like technicians who can input certain things into computers and get the results out of the computers. And you'll have to ask the question, if there are so many of these people doing it, what is this idea of a scientific method in all the production of science? Where are they asking, does this, what kind of logical connection is there between my hypothesis or my data and my, you know, data and hypothesis or data thing? There are a large number of work being done on visualization techniques within science, etc., very well represented by this statistics, the 2019 Google Scholars list of 7 most highly cited publications, the latest one. And out of the top 5, 3 are in artificial intelligence. And out of the 7, 4 are in artificial intelligence and computer science. The 2 are on obesity. One on obesity in the US and one on obesity globally. And these are the most highly cited publications of last year. We have to recognize, you already by looking at this, you know, I mean, you can do a lot of interpretation of this. My point in this is to talk about this sociality, the social production of this knowledge in this science. Why is it, if, you know, that these are the highest cited, you know, publications? Why is it that, you know, the notions of method which are addressing the questions in AI are so different from what we've been talking about in classical idea of method, which scientists still want to use as an ideal of scientific method? What they're doing in computational physics, for example, or computational science in the sense, is a completely different ball game of what kind of logic they are actually doing. And then, of course, medical science does it in another thing. And in this, if you and there's another very important aspect to this. The most cited paper in this is actually by the Microsoft research team. It's not from the university team. It's not one of these regular scientific physics lab or chemistry lab. It's a Microsoft research team, which is actually pointing to how traditional models of science have totally changed from government labs to private support. One of the major questions in discussion on Indian science is to really raise the kind of private support for doing science along with this large government support. And most interestingly, if you look at what kind of these kind of work coming from, new kind of science, new kind of products, new kind of processes are being developed, not in the traditional scientific labs, but from artificial intelligence labs, computer labs, pharmaceutical industry, chemical industry. And many of them are running on a completely different logic, both the different social logic, the logic of society which drives them, very different from saying, I want to look at the skies and see what is there. That's become a very small percentage of science anyway. And in all of this kind of an enormous amount of production of work, its notions of logic are very different. There is a completely new way of looking at it through the logic of machines, how machines can handle big data, how machines can discover patterns, how they match from movement from data to hypothesis and theory and so on. And a very important, equally important question, that they're also being dictated by rich private companies. We know the impact of it on medical science and the pharmaceutical industry. And we know what is happening to the kind of science which is being done here. And this is not a criticism on this very important community of medical scientists who are doing, especially now in COVID time. I think what they are doing is extremely important. But we should remember what many of us in the ordinary people of society have been saying about medical science, that it has become reduced to technical assistance job. You look at printouts of lab reports, you don't have to take it to a doctor, you can read it and say certain things, and that's what's happening. And this Google doctor phenomena, you look at it online and you go to the doctor, and doctors hate it, of course. But where is the function of the scientific, when every time medical scientists say, oh, we are science, we are scientists, what is this point of deduction and induction that they are doing? Where have they moved? They have not discovered the medicines. They have been told for this particular migraine, you give that medicine. What kind of a scientific practice is that? So this raises, I mean, I think it is impossible to talk of science today without recognizing these major changes which has happened in science, and the recognition that science and knowledge is being produced for profit, not for knowing. That innocent notion of saying, I'm looking at the world, stars and planets and animals and discovering the truths of the universe. So much of it is being driven through the notions of profit. What does it imply for the notion of scientific method? And I was reading a piece a few years back, actually, not even latest, that how there are already labs which are running by robots, and the scientist in charge of the lab is quoted as saying, these are better than having PhD students because they can work 24/7. I don't have to worry about dealing with them. And they are also doing cognitive step here. Robots are not just, it's like not like like a car assemblage. It is actually doing quote unquote thinking, doing complex tasks of cognitive recognitions of various kinds. So I'm going to stop here and say that given this does not negate the idea of scientific method, nor does it negate the importance of logic within science. But I'm saying for social scientists, here is a great opportunity to reflect that the social phenomena called science, which is involved in this kind of reproductions and legitimizing through the ideas of knowledge, and knowledge itself legitimized through profit, and being done on completely different logics of machines as much as logics of our primitive human mind, deduction and induction and maybe abduction. And with all this, when scientists then keep telling you that to understand, the problem with humanities and social scientists is you're not as logical as scientists. You have to give an account of it. You have to ask them, what do you mean by logic? How is it that the logic of individual thinking, which is very different from the logic of science, how does it matter to me in my understanding of social phenomena, in my understanding of how I should teach, what education is, what religion is, what caste system is, and so on. So I'm sorry, I think since the question took a little bit of time, I'll stop here, because what I want to do is to, the next one, to complete a little bit on the everyday practice of science, to then look at the question of how we can actually address this question of social science and the practice of social science in terms of these connections with logic and similar terms, which we have seen so far. Okay, maybe we have a few questions we can type in, like we've been doing. Is Kirish?
Yes. I think we'll open the chat box for question and answers, so that people can post their questions here. Yeah. Thank you, Professor Sundar, for the talk.
Yeah.
Hello. Yes. The audience may please put down their questions in the chat box.
And like I said, like last time, I will begin with them so that we can cover some parts of it. And this also helps me, focus on certain themes, because it's such a large topic. It can connect me to, to bring it to certain questions of your interest. So. Ritesh, if there are any quick questions somebody wants to ask now, we can do for the next few minutes if you think that might be
Okay.
fine.
Yeah.
You know, because I pick up all these questions and definitely deal with all of them. But if you think there is somebody who can immediately connect to the questions we're asking, something which they can think about before they come on Thursday, they can ask now.
Okay. So I guess we'll take up a few questions, and the floor is open. You may please raise your hand, and we'll try and accommodate a few questions. Ekta has a question.
Yeah.
So should we start with Ekta? Ekta, you may please ask the question. Ekta, you may need to unmute yourself. Ekta? Or should we go to Jinesh?
Hello.
Yes, Ekta is here.
Hi, thanks, Ritesh. Professor Sarukkai, I just wanted to ask you if you could elaborate a little bit on this idea of how logic used in AI and allied fields is different from the traditional ideas of logic that you mentioned earlier. I think that point was not elaborated enough and it was difficult to understand the difference. In addition to that, what does this mean for social sciences? Thanks.
Yeah, no, okay. So, I think the point is that logic itself has become, far more complex. Within the discipline of logic, there are many different kinds of logics. There are, many different models within mathematical logic. There are now fuzzy logics which have come into play. And many of them are about, machine language, getting tasks to be done by machines. It's basically about instructions and converting those instructions into tasks, right? So the questions of the traditional scientific method in terms of looking at analytical structures. So when we say mathematics, and we say when mathematics in the classical sense is deductive, which was the famous Russell's project, which I told you about, the aim is to be able to see, whether all mathematical statements can arise as particular forms of conclusion. So it's like if 1 + 1 = 2, then 2 + 2 = 4, those kind of, following something given something. But even there, we saw that when more complex branches of mathematics comes, the logical systems there can be far more complicated. It is also possible to see how mathematical cognition functions at the level of visual cognition, which has been largely my own interest in my work, because it has, I think, implications for maths education, that a lot of students learn mathematics not as logically coming to a conclusion given certain premises or given the prior statements, but coming to recognize patterns through the ways you write things. Even writing of mathematics plays such an important role. So, so the point here is this, that computers in a sense can allow you access, can allow you capacity to control a huge amount of data and computation, which you cannot even imagine doing. And I think for a large amount of science which is being done today, including modeling of molecules, modeling of drugs, there are even modeling of physical systems are done through computers now. What you might have to do with your typical mathematical analytical modeling for years with tens of students can now be done in computers. So there are physics people who are actually far more better, physics and chemistry people who are actually far more better in doing computers than what you would have called as traditional training in theoretical chemistry or things like that. So I was talking about this whole domain of things which have now become part of the ease of ways of handling it. And that's really what I mean. And I think for social science, this is where the real synergy between social science and this, scientific method is really coming in, because many of the social processes are big data processes. I mean, today, environmental science, climate change, etc., are being so much taken into the modeling groups, the science groups. you have very little say among social scientists who still are vainly standing in the back and putting their hand up and talking about social categories and so on. So there is a large amount of movement towards that. I was just looking at something, I forget what, I think it's called, social physics now, coming back to that term, Comte's term. And apparently there's a big revival of massive number of scientific papers, etc. in that. So that's a very different way of the methodology itself becomes very different. Yeah.
Take a couple more hands I see. Jinesh, I think I need to. Yeah.
Yeah. Thank you, sir. Yeah. May I go ahead?
I feel like the desktop is going to crash one day.
I request others to mute their mic, please. Yes, Jinesh. Please go ahead.
Yeah. Thank you, sir. So I was particularly interested in the works in philosophy of science. I've read some of them, like Kuhn's.
Yeah, I can hear you.
I guess.
To exercise my host authority to mute some of them. Yeah, Jinesh, I think now you.
Thank you. So I was reading Kuhn's The Structure of Scientific Revolutions and some of the later works which were influenced by this particular thing. I was more curious about how was this received within the scientific community, because it in a way changes the entire picture of that linear progress towards truth and the notions of paradigm shifts, and there are many certain revolutionary ideas within the philosophy of science. So how was this particularly received by the scientific community, by the scientists working within natural sciences? And what are the subsequent developments with respect to Kuhn's?
Would you like to take it up?
Yeah. Can you hear me? No, as I said, Kuhn was more acceptable, partly because of his background in science and also because of where he was. And I think, the scientists were not very threatened by what he was really saying. They, of course, like in many of the things in philosophy of science, internally they may accept some things, but depends on what they would share with other groups. Kuhn has been one of the most influential figures in the, within history and philosophy of science, has had, a lot of what we call traction within the society. A lot of people have written about Kuhn, criticized him, and that's a very good thing, because in academics, somebody criticizing you is taking you further and trying to, build upon your work. But the later philosophers of science have not had that much of luck, in the sense that there was a period which is very much captured by people like Stephen Hawking, Steven Weinberg, who was a Nobel Prize winner. They took on the position that which was very antagonistic to philosophy of science. They were sort of okay in a sense with Kuhn at that time, and by then it was already 20 years or more. And this attack on philosophy of science begins systematically within the science community by including things such as, philosophers don't know anything about science, so what can they tell us about what we are doing? And that has remained such a deep problem, even in, across the world, even today in programs in philosophy of science. And some person asked the question for last session, should we know? The question was, how much science should you know before we can talk about science and society? How much science should you really know before you, make comments on some things about science, even do history of science or philosophy of science? And this has often been used to ridicule philosophers of science by saying, no, you don't know what you're talking about. So there needs to be a lot of cross-cultural learning of both science and what history, disciplines like history, philosophy, and sociology aim to do. That they're actually doing something else than what scientists are doing. And that, sometimes it is helpful to know some science which you write about. Sometimes it's, you may be looking at different types of structures which you are making, which you are commenting upon. And it's really not about what the scientists are doing. So yeah, in that sense, I think Kuhn has had a far better time than many others who came after him. As I said, the tendency for some philosophers, I find that very unfortunately increasing in India now, to think that philosophers have to be cheerleaders for science is, I think, really negates much of what philosophy as a discipline has been historically, right from early Greek times within the Western tradition onwards. You can't just be saying that what the scientists are doing are right, but I'm going to add a small little bit, which doesn't matter to the scientists anyway. So I don't think that's really a function of philosophy of science, but that's my view. I may be wrong, or I may be in a different group within philosophy of science. But definitely philosophy of science is a very, very deep role to shine light on the structures of scientific thinking and practice in ways which a scientist herself may not be able to do.
We have a couple of more hand raises, but I think we would have to close the session for the day, and we can request the people who have raised their hands to also put in their questions. Would that be okay? Or
yeah, sure. I'm fine. If you want to take one or two more, I'm fine. But if it's late, we can stop. I have no problem. Yeah.
Okay. So perhaps we can take one more from Aniruddha. Aniruddha, you may please raise your question.
Yes. Am I audible?
Yeah.
Yes, Aniruddha.
Yeah. Thank you for wonderful lecture, sir. I would like to ask a question which is very much related to what you were talking just now, that the problem with truth is verification, and in that verification process, science, what science does is usually takes data, empirical data, and then there is a part of interpretation to verify the truth. So is the role of philosophy just to is in that realm of only interpretation of data, what kind of interpretation you can do and what kind, so in that realm philosophy can aid to science? And that's first part of my question, and second part is mainly about does philosophy really has any place in a particularly in the fields where science is doing very much well? For example, neuroscience is doing very much well in figuring out what emotion is. And I'm a philosopher of emotion. I'm doing PhD right now. So what kind of role philosophy has in today's era?
Yeah. Okay. This is a lot of tough questions there. Mainly because we see what has happened to philosophy across the world, particularly in India. Yes. So I think there's one point which is very clear. Philosophy of science is about philosophy. Okay. In the sense, if at all you have to do philosophy of science, you have to ask, what are you bringing to the understanding of what a scientist has already said through your categories, through your forms of reason, right? So you might raise questions which arise from what philosophical insights. For example, simple things like, how have concepts been understood within neuroscience itself? The question, what if there are alternate theories of mind, which many philosophical traditions have? What kind of implication would that have to your understanding of a neuroscience project, a neurophenomena? What really constitutes neural, individual phenomena? Is it Are there identity conditions for it? These are, I'm just using it as typical physics, philosophical questions that you ask, right?
Right.
So when you ask these kinds of questions, you may, of course, draw upon the philosophical literature to answer them. And scientists may say, well, it doesn't affect my work. I don't learn anything from it. That is not the issue at all. We are not doing science, okay? But we still hope that, so for example, if suppose somebody says science has been built with a very hegemonic structure, using only certain kind of people and, rejecting a large number of people, somebody might say, well, so what? Is that science is very different or what? That's not the question. You are understanding it as a social process. So for example, in feminist epistemologies raise the question of, the woman's question within science. And if somebody, the standard question, I've heard this 100 times, which is, oh, if women had done science, would Newton's law be different? I'm saying, look, sorry, that's not I can answer that. I can give you a very good answer for that, but the way you phrase the question itself is wrong. The point about my asking that question as a sociologist is to understand the process of this social process of knowledge production within societies. It's like what Marxism does with class and labor, for example. So we have a domain, and many people might think, oh, what is the use of this domain? I think it's upon all of us who are in the field to show how useful our domain really is. Okay, and I think, for example, at least a part of my understanding, whether scientists accept it or not, when I wrote my first book on science and language, in order to understand how scientific texts are written, I not only discovered an enormous amount of interesting literature on answering the question, what are the cognitive strategies of reading scientific texts? How does one read a pictorial book? Where is the question of language and translation in it? I think all of them are very insightful. And if readers take me seriously and read it, it was insightful for me. I had done science. I knew something about little bit of what it was to do theoretical science. But for me, the whole understanding of mathematics changed when I did philosophy. To understand what is this thing about using mathematics in the sciences, it still remains my major point of interest in my own work, is how does this thing about some symbol, some human creation called mathematics, why should it matter so much to knowledge of nature? So I think, there are a lot of interesting ways in which we can contribute. It does not have to be to the dictates of scientists, but rather it is upon us to show why what we are doing is so interesting and insightful. And I know many scientists who have actually been very inspired by it, even contemporary scientists whom I have met both in biology and the physical sciences, who have really been influenced in their work. They are not doing philosophy, but they've been very influenced in their work through philosophical questions. And if you really look at 20th century, early 20th century, we're ranging from people like Einstein to Poincaré to Schrödinger to Heisenberg, all of them were trained in philosophy, were deeply interested in philosophy, saw many of their questions as being philosophical. So
isn't that the problem, sir, that scientists doing philosophy is a fine thing, but philosophers not doing science and then still claiming that they can add to world of knowledge? That's the issue.
No, let me clarify. Scientists are not doing philosophy. Einstein didn't do philosophy in the traditional sense of philosophy.
Yeah, of course.
I'm saying he was inspired and catalyzed by philosophical questions, just like Schrödinger.
Right.
And his understanding, Schrödinger's exposure to various philosophical traditions, including the Indian philosophical tradition, for him, in his words, was very influential. But he didn't write on Advaita. He wrote quantum theory. Right? So all I'm trying to say is they are doing that part of it. We have to see how we think about new questions in philosophy, new concepts in philosophy, and maybe even ask a question, as much as science has changed, how is philosophy going to change? To me, the question is more a question about social sciences. I still think their understanding of science is, very traditional. And they're still responding to questions from scientists to them not with enough confidence, not with enough training. So I keep coming back to the question, why is it our social science students, including education students are not trained in basic course in philosophy or a basic course in history and philosophy of science. They live in a scientific technological world. They're making sense of it in every way. Why is it that our institutions don't think we should, even among the social science community, why don't they do it? Why doesn't all our IITs and ISS, which have so much money, they think all the humanities department is primarily English teaching?
Right.
Why do they do that? And what is the social science community doing about it? So that's a question we have to all think together. It's not a quick, easy answer, but, we will think about it and see where we take as we,
Yes.
do this. Yeah.
Thank you, sir. Thank you.
We have one more hand raised, but I think we are into 7:20, and do you want it to be closed, or would you like to take
That's
that?
okay. If you think we should take it, we'll take that. Maybe.
Okay. So Alok, that's the last hand raise that I see, and it would be the concluding question for the day. Alok,
Okay.
please, could you please ask?
Yes. Thank you.
And
Thank you.
Sundar, could you please put on your
Okay, I will
video?
try to brief.
It is not opening, so I'm
Okay,
trying.
it's okay.
It's not
okay. Am I
allowing
audible?
me to do that. Yeah.
Am I audible? Okay. So, sir, thank you very much. This is really a very informative session. And I just want to ask you, when you were discussing the theories and the principles in your lecture, just try to give the examples. As you have given the examples while discussing the theory, the deductive and inductive approach of thinking and asking anything. And what my question is that actually we are the field workers and we actually work with the teachers in education, and while making dialogue with them regarding the conflict of society, religion and science, at some point of time we got stuck while introducing science in terms of practices of society and the religion. The people somehow say, no, at this point of time we are not going to take the scientific theories in the practice of religion and the practice of societies, like in the belief of something like God and the morality. They usually say, no, there is a kind of energy in all around us, and in that context we could not take the question of science. Or we can take the examples of Sabrimala, that they usually talk about, no, this is the belief and this is the called the historical constitution of that pilgrimage that he told that. But in that context, what should be our way to make a scientific approach to have a dialogue in the context of scientific method? Are you getting? Am I?
Yeah. This is this is what I was trying to set up today, to even ask what is a scientific method. So whether that is even practiced within science before even asking the question about religion. Okay. That in what sense is it that they are asking those critical questions within science itself before we ask that about God or whatever, faith and so on. So I'm leading to that, because what I want to set up today will come for the next session when I look at society. Just like we have analyzed science, we can now look at the idea of society and the social and see how to understand objects, social phenomena and social objects, quote unquote, like religion and so on. And how does, what kind of a method, is there some kind of a scientific way of looking at religion, for example? Does it make sense? Is that how we should be looking at it? And what are the challenges to that? So I will come to address part of your question in the next session on Thursday. Yeah.
Okay. Thank you. Thank you.
Thank you. Okay.
For today's talk, and thank you to the audience for being so patient and working this way through this technological platform. Yeah. So we look forward to the Thursday session.
Thank you, Ritesh. Yeah.